Well, I'd like to say it's turned into a screaming toddler, but yeah. Okay, good evening. I think the last time I spoke to OSHUG would be November of 2011, which was really just the start of selling Nanode, and I think at that meeting I announced that I was off to California for most of a year. Well, I'm back from California, and I'd like to give you a bit of an update about how the project's gone so far, and one or two lessons I learnt on the way. Let's get started. Okay, Nanode is it's an Ethernet gateway product, and it arose back in 2009 when I was working for Onzo, the energy monitor people in London, and we were doing some work with some of the early gateway products that were available 3 years ago, and there didn't seem to be much to them. They all seemed to be quite expensive, and I wanted to have a go at creating a much simpler platform on which enthusiasts, hobbyists could experiment with electronics connected to the internet. A few months went by. I found myself stranded in Shenzhen for a few weeks in a Chinese hotel with not much to do. So I got thinking about the idea, and I also, when I was in Shenzhen, I met some people that have proven to be very good contacts, being able to source components very cheaply, and also be able to take on some of the subcontract work of what's involved in producing low-cost hardware. And around about the same time, I started experimenting with Arduino, and I think around about the summer of 2010, ideas started to gel, and I decided that I'd have a go at producing a little product. I think it was Arthur Ransom who wrote a book many years ago called "We Didn't Mean to Go to Sea," and I think I don't think I set out to objectively get involved in Nanode. It's just something that evolved. What seemed a good idea as a little hobby project grew into something a lot larger. This was the first prototype. I'd like to say still in daily use, but it still works. Built on a breadboard. This was what kicked my Ethernet hardware experimentation off. I felt that if I can build it on a breadboard and get it working, then it's in with a chance of working on a proper PCB. So what we have there, I think I've probably spoken to a lot of you about the hardware in the past, but we've basically got an 18 mega 328 on the right hand side. We've got a microchip ENC 28J60 Ethernet controller on the left hand side, a mag jack, FTDI cable connection, and some glue logic in the middle, and that is about it. And that's what really kicked the process off. So the concept was to combine a Mega 328 with an ENC 28J60. It wasn't the first time it had been done, but that combination proved attractive because they were available as through-hole components and readily, easily experimented with. and to put them on a small PCB so that you've got some standalone electronics that you can do simple connectivity to the Ethernet. That's the idea. The idea was to market it as a low-cost self-assembly kit. As well as the 3 chips, there was only about 30 other components, and it's the sort of thing that's relatively straightforward to put together for most people. Wanted to maximise the use of an online shop and use PayPal for almost all financial transactions. This was very much a sort of backroom project, almost a kitchen tabletop exercise. It was to earn some extra cash, and I had no real aspirations of turning it into a fully fledged business at that time. And the idea was to target the hobbyist, the hacker, and the enthusiast. And from the breadboard design, I put it onto a small PCB. The influence of the Arduino is there. It's compatible with the Arduino shields, and as you can see, it's entirely through-hole construction. And so I made about 20 of these, and these were distributed to fellow enthusiasts, basically my beta testers. So that was around about May of 2011. We decided that we'd make a few more. The early prototypes were soon gone to people that wanted them. So I started off getting the people at the London Hackspace interested, and the idea was we'd make about 50 of them and share the costs of production of a small batch of PCBs. Well, the original 50 within a few weeks had escalated to 150, and the following month we did 250 and another 250 the next month. So the summer of 2011, most of my spare time was spent putting this together, you could make a batch of 20 kits in about 2 hours. The components were purchased in sort of 100-off quantities, generally from Farnell, Rapid Electronics, to get the most favourable price. And in order to kickstart things, we had a Nanode weekend that was held at the London Hackspace in August of that year, where we had about 40 people through over the weekend, and they all made the kits up and took them home with them at the end of the weekend. What was going to be an initial batch of 50 was rapidly up at the sort of 600, 650 figure. So that was all going swimmingly well. So here was the first production version. Because of the connection with London Hackspace, we put the Hackspace logo in the middle and tidied up the PCB a bit, and generally turned it into a more attractive product. Here's what came in the original kit. It was all put together in one of the pink plastic bags. You've got the PCB, you've got the ICs and the sockets on a bit of conductive foam, which we call the IC raft, a dozen or so resistors, and 1 or 2 other small passives. So that was the basic kit, and we were selling those for £20 to £25, depending on how many and to whom. This is a view taken in this very room actually. We had to keep up with demand, and there's something like 160 IC rafts being laid out there on tables, and I think I was probably programming the microcontrollers with the Boak logo that day as well. So it was a case of chasing after demand, keep up with demand. So I guess by the autumn of 2011 I was starting to look to my contacts in Shenzhen. A PCB that would cost you £1 in the UK was something like 35 pence from China. Many of the components are produced in southern China and available very cheaply from the electronics markets. A friend out there acted as my personal shopper. I'd send them off to the market in Shenzhen, and a couple of weeks later a vast stock of components would arrive. But also we worked towards getting the kits put together in Shenzhen. It kept my colleague busy, and it also kept the costs down. So that's where we were towards the winter of 2011, around about the time that I last spoke here. In this journey with Nanode, I've formed partnerships and working relationships with a number of different organisations, and they've all brought something worthwhile to the project. Very quickly after producing the first prototype, I was contacted by a company who are based in upstate New York. They're Wicked Device. They had a range of electronic kits for hobbyists, and they called me up one day and they said that they wanted to market the Nanode in North America. So I said, fine, no problem. In the intervening year, they've probably sold about 1,000 or so in North American territory, which keeps the costs of shipping these little kits around the world, it keeps that down to a minimum. They then went on to get involved in a crowd-sourced project, the air quality egg that some of you may have been involved in, may have heard of. And the Nanode board was chosen to be the Ethernet gateway for that product, and that project was launched on Kickstarter in about April of last year, and very quickly they had over 1,000 pre-sales. So part of the deal with Wicked Device was that they were going to productionize the Nanode and turn it into a surface mount design. I was busy with other things on the west coast of the US at that time, and so I was quite happy to see another organisation take the project and move it along a bit further. And also in the UK, in Wales, my colleagues from Open Energy Monitor, they also were interested in using Nanode as the RF version of Nanode as their Ethernet gateway, and that ships with most of their energy monitor equipment. So very quickly there were a handful of organisations who were all selling Nanode as part of their product offering. Here is the surface mount version. These were hot out of the reflow oven in October of last year. This is the board that's used in the air quality egg, and it's basically the same design, just productionized with surface mounts. And these are about $25 to produce. So complete with RF module. So the product in the course of 2 years had evolved from a simple breadboard prototype to a fully fledged product. Future plans. The lesson I've learned, I think, in the last year, 18 months or so, is that you're really trying to squeeze a quart out of a pint pot with the Mega 328. From a resource point of view, it's especially stretched in terms of available RAM. We're currently looking at the Mega 1284 as a potential replacement for that. The aim is to maintain Arduino IDE compatibility. There's still a lot of energy left in the Arduino project, so tapping into that and working in parallel is a worthwhile move. Spin-off products including different variants and the likes of low-cost wireless nodes. These are things that we have in consideration at the moment. Either designed by ourselves or bought in from other hardware vendors. So as to complement the Nanode RF. Top tips, things I've learned along the way. Keep good records. Your accountant will thank you for them. Never underestimate UK import duty at 20%. Just when you thought you were getting that nice big box of goodies from China and DHL phone you up and say, you're going to send us 500 quid for us to release it for you. That comes as a bit of a shock to the system. I think one lesson is always try and mark up your product by about 250%. I've heard variations on that from about 2.3 times to 2.6 times your actual costs, and that means that you can afford to make some profit from it yourself. You may choose to use another organisation as a distributor, and they can afford to make some profit. And it also covers unexpected bulks out of the blue, like import duty bills and accountant's bills and all the day-to-day stuff that small businesses have from day to day. So there, beware of the Raspberry Pi effect. Open source hardware, like any other technology, is subject to disruptive factors, and out of the blue came the Raspberry Pi, and anybody who had a spare £25 in their pocket went out and bought a Raspberry Pi, and that took a big, a large number of potential purchasers of Nanode. The organisation cannot compete with Raspberry Pi. I mean, we're products as different as chalk and cheese. So when you find that a lot of your potential customers have jumped ship, as it were, you have to recamp and think of another strategy to keep sales going. Hardware costs are continuously falling. When I started the Nanode project 2 years ago or so, an Ethernet shield for an Arduino would cost about £35 or so, and nowadays you can look on eBay, and there are clones of the official Arduino Ethernet board for as little as £6.70, which in my book barely pays for the WizNet controller chip. So hardware costs are constantly falling, and you have to be aware that you're not getting in some race to the bottom. Try and remain competitive and innovative. Every product has its day, and if you can have something in the pipeline to revitalise it, or something innovative, then that always helps to strengthen your business. That's all I was going to say. We're going to do questions now, or?
We definitely have time for questions, yes.
Can you give us some examples of where these were used, or sort of what they were used in?
Right. The Nanode is basically an Ethernet gateway that allows you to form low-cost wireless sensor networks that all communicate back to some server via the Ethernet. And the two projects that I mentioned were the Air Quality Egg, which was basically a wireless sensor which had carbon monoxide and nitrous oxide and dust sensors on it, and that data was gathered, concentrated, and then passed up to a web server using Nanode. The other application was the Open Energy Monitor, where you may be monitoring your electricity consumption, or your gas usage, or your water usage, or the temperature in various rooms around your house, or the performance of your central heating system, and that sort of data can be passed very simply up to a web server for collation.
Oh yeah, cool. So you also mentioned that it had RF module support. What standards?
Yeah. We use a low-cost module by Hope RF. It's available either in 433 megahertz or 868. It has a usable range in suburbia of in excess of 100 meters. For example, if you're monitoring something down the bottom of your garden, you can quite easily get that data back to wherever your router and the Nanode gateway happens to be located.
And that, sorry, I just have one more question. Those RF modules, how do they actually talk to the board? Is it just like SPI or something like that?
It's SPI bus, yeah.
So firstly, thank you for that mentioning the Internet of Things several times. Did you find, so this is open source under which license?
It's Creative Commons share alike.
Right, so this is just a curiosity, but did you find that people copied it, abused your the licensing terms in any way over this time?
I don't think anybody was mad enough to. I think plagiarism can be one of the best forms of flattery. My Chinese friend is threatening to introduce Nanode to China, I wish him well with that enterprise. The open source community that sort of gathered around offshoots of the Arduino project tend to be quite an open house. Someone comes up with a good idea and other people augment it and share it and pass it on, and that's generally the philosophy under which I've worked with the Nanode project.
How does that work with the air quality egg? Is that not a funded project?
It was. I receive a small royalty for.
I mean, are they open source as well?
They are open source, yes. But I receive a small royalty for every board that's produced by Wicked Device in the States.
Yeah, I just wondered if they were kind of anything open source.
No. What's the power budget?
The power is probably 150 milliamps at 3.3 volts. The Ethernet controller chip takes at least 130 of that at 3.3.
Would it be feasible to run these things off solar panels? I'm thinking about remote monitoring without.
Yeah, it would. There is a sister product called the Nanode that is basically a small wireless transceiver that has a much lower power budget, and that is probably what you would locate close to your solar panels to do your voltage and current monitoring, and that would talk back to the Nanode.
So I wasn't thinking about monitoring the solar panels, it was about using solar panels.
Oh, to power it, yes. Yeah.
Were you put off by the fact that in the States, I believe there was a board called the Rabbit? It wasn't Arduino compatible, but it was a single board. When it was brought out in '96, I think it was an Ethernet only. And later on in about 98, 99, he developed the Internet Stack, which was a development. So were you put off by the commercial?
No, I don't think so. I mean, we all build on work first done by our predecessors, and it takes a certain amount of insight to see a novel opportunity from something that already exists. And certainly when I commenced this in 2010, there was quite a novel value to it.
I was going to ask that recently the Arduino guys have pushed out a lot of stuff, a lot of products and things. And so in the light of all of that, it seems like going up to another higher order Nanode product, so even more risky than when you started with the one that you
indeed, but the Arduino kit in general is very expensive.
Yeah.
And in this current economic climate, people don't have 40, 50 quid in their pocket to buy something on a whim. And one of my strategies is always to be able to sell it at the lowest possible cost.
Yeah.
So, yeah, but I take your point. Yeah.
I think the other sort of, well, it's not a related question, but one of the big constraints with the existing Nanodes up to now has been the stack,
Yeah.
the Ethernet stack. So if you did go up to another product, would you stay with the ENC chip, or would you go up?
I think with more resources in the microcontroller, there is a better stack available for that ENC chip. The limitation is not with the chip; it's with the
the space, yeah.
Yeah.
That's right, yeah. It is an alternative, and the other stack works really nicely. It's just that it feels like the standard.
Yeah.
Apologise, it wasn't 96, it was 2000. So.
Yeah.
I think it's probably now time to thank Ken very much for